Good, good day, students. So, welcome back to DBMS course. Now we are in chapter 4, data models, and we are now in the part 1 sessions. So, in this chapters, we will study more about data models, which includes the hierarchical models and network models and the other models in the next session. And for the hierarchical models, we will look into the tree structures, and then we'll look into examples and diagrams of the relationship of the tree structures, and then the virtual records, which is the solutions for the tree structures. And then after that, we will look into another model which is called a network model, and it's more like a graph structure, and we will see some of the examples of the relationship in these models. Okay, I think we need to just start it. All right, so we need to understand what the data models is and some of the categorizations of the data models. So let's start by understanding what a data model is. So a data model is a framework that organizes and structures data for various entities that we want to represent in the database. It serves three main purposes. The first one is called uh, structuring data. Okay, so structuring data here is defines how data is organized. It includes the types of data, and then their relationship and how they are stored. And it also defines operators for data manipulations. It provides a set of operations that can be performed on the data, such as adding and then updating, deleting, and query of the data. It also ensures the data accuracy through some of the constraints. It enforces rules and constraints to maintain data integrity and accuracy. So in simple terms, we can say that a data model is a conceptual method of organizing and managing data in a way that is both logical and efficient. All right, data models can be divided into three main categories based on the concept they use to describe the structure of the database. The first one is called high level or conceptual data models. So these models are close to how users naturally perceive and interact with the data. And they use concepts such as entities, things that we want to store information about, and the attributes, which is about the details about those entities, and the relationship, how the entities are related to each other. And the next categories is called low level or physical data models. So these models more focus on how data is stored in the computer. They describe details like record format, how the data is organized in storage, and then record ordering, the sequence in which data is stored, and access path, which is how the data can be accessed efficiently. These models are actually meant for specialized users like DBA, or we can say database administrators, for not for the end users. And the next, okay, the next the next type is called representational or record-based data models. So these models use what is called record structures to represent data. They hide some of the storage details, making it easier for end users to understand and work with the data. And these types includes the network models, hierarchical models, and the relational models. Okay, for the relational models, we will discuss in the part 2 of the chapter 4, which is after the midterm exam. Now let's dive deeper into high-level or conceptual data models. These models are designed to be intuitive and easy for users to understand. So here are the key concepts of the high-level data models. So the entities are the object or things that we want to store information about. For example, in a business database, the entities might include customers, products, and the orders. Meanwhile, for the attributes, is the concept of properties or details about the entities. So, for instance, a customer entity might have the attributes like name, the address, and phone number. Moving on to the relationship. So, the relationship define how the entities are related to each other. For example, a relationship might exist between the customers and orders, which indicate that customers place orders. So this high-level concept will help the users to easily visualize and to understand the data structure without worrying about the technical details of the data storage. Next, let's explore low-level or physical data models. So these models will focus on the technical details of how the data is stored and accessed in the computer. So the key concept which include the record the formats, record the orderings, and access path. Okay, so for the record format, it's describe how data is physically organized in a storage. And this includes the layout of the records and fields within these records. Meanwhile, for the records ordering, it defines the sequence in which records are stored. This can affect the efficiency of the data retrieval and the updates. Next is the access path. So the access path are the routes that the database management system uses to access the data. Efficient access path can greatly improve the performance of the data operations. So in this case, low-level models are mainly used by database administrator and system designers who need to optimize the storage and retrieval of data for performance and efficiency. Okay, now let's look at representational data models, or we can also call it record-based data models. These models use record structures to represent data and usually are commonly used in commercial database management system or DBMS. So the key concept of this type of data models includes record structures and the easiest used or user-friendly. Okay, when talking about the record structures, the data is organized into records, are similar to a row in a table, and each record may contain fields that store individual data items. It is also user-friendly, right? Because the representational models hide some of the complexity of the data storage, making them easier for end user to understand and work with. There are some types of representational models. It includes the network model, hierarchical model, and relational model. Okay, and we will look into each of them in this chapter. Okay, so the network model represents data in a graph structure where the entities are nodes and relationships are edges. Okay, meanwhile, for the hierarchical model, organizes data in a tree structure with a parent and child relationship. And then the last types is called relational model. Okay, so the relational model uses tables to represent data and relationship, and making it the most popular and user-friendly model. Now let's focus on the relational model, okay, which is the most widely used representational data models. And here is why it's so popular. First, it's because it's table-based structure. So the data is organized into tables where each table represents an entity, and each row in the table represents a record. Columns represents the attributes of the entity. And the second reason why it's widely used, why it's so popular, is because the simplicity and ease of use. So the relational model is easy to understand and use, even for people without a technical background. So you can perform operations using simple and powerful querying language like SQL, the structured query language. Also, the flexibility. It allows for flexible data manipulations and querying. So we can easily add, update, delete, and retrieve data using straightforward commands. And it's also efficiency. Okay, the relational model is designed to handle a large amounts of data efficient and making it ideal for many commercial applications. So, to summarize, data models are essential for structuring and managing data in database, and they provide a systematic way to organize data and then to perform operations on it and ensure its accuracy. And then we have discussed the three main categories of the data models. I hope you still remember. The first one is a high level data models, and then the second one is low level. Okay, I will write it down here. Okay, the first one is, oops, first one is the high level data model. Okay, the second one is the low level data models. Okay, and the third one is the representational oh my god, it's not enough. Okay, but I will just think I will write over here. Okay, it's the relational model. Okay, so we have three categorized of the data models. Okay, so you need to understand this. So it helps you to design database that are both effective and user friendly. It is also support a wide range of applications and user needs. So we need to learn about this kind of data models. All right. So next we will understand the hierarchical model based on the tree structure. So the hierarchical model uses a tree structure to arrange the data. Let's think of it like a family tree or an organization chart. The records, it's about each person or a box. In this tree is a record, and a record holds different pieces of information. It's called the attributes about something. So for examples, a record for a person might include their name, age, and address. Okay? And each attribute will only have one value. For examples, the attribute of age can only have one number, like 25. And then links, yeah, links. So links is like a line or arrow that connects one record to another. It shows how they are related. So it's more like how we show a relationship between one to another. So for examples, a parent record might cling to each child records, just like how a parent connects to their children in a family tree. So in summary, the hierarchical models will arrange the data in a tree with the records connected by links, and each record holds a set of details, which is called the attributes. A tree structure. Okay, so a tree structure is a database is a way to organize data where everything is arranged in levels, yeah, kind of a family tree. So a tree structure is how we can explain the hierarchical model. So in tree structure, we have what is called a rooted tree. So rooted tree here, rooted trees over here. Sorry. It's here. Okay, it's the rooted tree. This is the tree with the top level point. Yeah, it's called root, like the head of the family. Okay, so the root is often just an empty spot or a placeholder. Meanwhile, for the forecast, forest, if you have a bunch of these trees grouped together, it will called forest. Yeah, forest. And then database 3, it's another term for these types of tree is database tree, and it's used to show how the records are connected to each other. Okay, so it's database tree. So what's the components of the tree structure? First is called rectangular boxes. It's a rectangular boxes. Okay, so each box stands for a record, like a family members in the family tree, and then also have lines. Yeah, the lines will show the how the records are connected one to another. So it's like parent and children in a family tree. And then the relationship between records can be one to many or one to one. So one to many is like a one parent with many children. One parent, many children. Okay. Meanwhile, for the one to one is one parent, one children. Okay. And then the relationship is shown by an errors. Yeah, so it's linked between the records. And then the child must have always point back to the children, sorry, the parent. The child must always point back to the parent. Okay, so in summary, a tree structure in a database looks like a family tree where different records are connected, and a row shows how they are related. I will give you an examples of this tree structure. Okay, so these diagrams represents a general tree structure used in the hierarchical database. Okay, so we have a root node here. This is the root node. Is the topmost node in the tree, and in this diagram it's labeled as the dummy node, and the root node does not contain any data. Okay, so it's an empty node that serve as a starting point of the tree. Okay, and we have the what is called rectangular boxes. So all of the records are represented by a rectangular boxes. Okay, and each box contains a records type, such as we have here a record 1, records 2, and the record A1, record AN. Okay, we also have lines here. Yeah, we have lines over here. It's the lined, also lined over here. I think I need to use another colors. Okay, choose. Okay, so this is lines. Okay, this is also lines. Okay, sorry. This is also lined. Okay, so the solid lines represents the links between parent and child records. And as we can see in these diagrams, there is a solid line from the dummy node to record 1, and then another from record 1 to records. Okay, sorry, it should be another color. From record 1 to record A1. And the lines indicate the hierarchical relationship between the records. We also have dotted lines here. Okay, we also have a dotted line here to show the connections. Yeah, for examples, in this case, a dotted line connects record 2 and records end, indicating a different types of relationship or less direct connections. Yeah, okay, so it represents less direct connections. Okay, so the parent-child connections in these hierarchical models, we can see in these diagrams, each record has one parent, right? So records 1 sorry. So records 1 is a child of the dummy node. Okay. Meanwhile, the records A1 is the child of record 1. Also, it happens for the other. So in this case, the relationship of these examples diagrams is 1 to 1. Yeah, one parent and one, sorry, oh sorry, it's not 1 to 1, it's 1 to many. Yeah, because one parent can have many children. Okay, So I have another examples to show you. Yeah. So consider the relation of working for, between, and the employee and department. Okay. This examples of this case for this case. And the records of employee consist of three attributes. We have name, and then age, and salary. Okay. Meanwhile, for the records of department consist of two attributes, the department ID and department name. So this is the AR diagram of the working for relationship. Okay, so remember we have this case for upcoming examples. Okay, so examples number one is the one-to-many relationship. So in this hierarchical database, an employee works in the one department, but a department can have many employees. So this is examples of one-to-many relationship. In this figure, as we can see, for the A picture, for the department records is include the attributes of department ID and department name. Meanwhile, for the employee, we have attributes of name, age, and salary. For the link, okay, the arrows from the department to employee indicates a one-to-many relationship, meaning that one department, okay, one department can have many employees, but each employee belongs to each employee belongs to one department. Okay, and then the figure B is the simple database. Okay, so we have root nodes here. We have root nodes here. It's the empty or dummy nodes at the top, and then the department nodes. Yeah, let me use another color. It's the department nodes. Yeah, so we have 1A department ID with the name of department cells, and then the 1B department ID of 1B, the name of the department is marketing. Okay, and under the 1A cells, yeah, 1A cells, we have John. Okay, it's the name of the employee. Sorry. And then with the age of 22, the salary 8,000. Okay, so we have another employee, Rohit, age 35, salary 10,000, and so on. Okay, so this is the examples of one-to-many relationship. The next one is one-to-one relationship. So in a hierarchical database, an employee works in one department and each department has only one employee. So this is an example of one-to-one relationship. So in this figure, as we can see that the employee records, yeah, this is the employee records. Right. This is the employee records. Okay, we have name, age, and salary. And then we also still works on the, oh sorry, I should use another color. Okay, so we still in the same records of department. We have attributes called department ID and department names. And watch out, this is the difference between the one-to-one relationship and one-to-many relationship. Okay, so the links, the arrow between the department and employee, it indicates one-to-one relationship. Yeah, meaning that each department has only one employee and each employee works in one department. So the lines is represented by these two arrows. Yeah, arrows up and arrows down. Meanwhile, for the B, yeah, it's the sample database. Yeah, we have root nodes here. It's the root nodes. Okay, this is the empty or dummy nodes at the top, and then the employee nodes. Yeah, this is the employee nodes. Oh, sorry. Employee nodes. Yeah, we have name, we have age, and we have salary over here. Okay, so John is 28 years, earns a salary of 8,000, and he works in the department 1A sales. Okay, and the other symbol of database as well. Okay, so the next relationship is called many-to-many relationship. So it's between employees and departments. Yeah, in this case, still we still using the same case. Yeah, still use the attributes employee and department. So an employee can work in multiple departments, and a department can have multiple employees. Okay, so this type of relationship cannot be represented in a single tree structure, as the tree structure follow a strict hierarchy where each child node has only one parent. So for a many-to-many relationship, you would need to represent connections that violate this one parent rule. But the two separate tree structure are used. Okay, so we still have the 4.5 diagrams on the left side of the slide. And then for the 4.5a, it shows a hierarchical relationship where each employee in this case is associated with one department. Yeah, so if you notice, the arrow is this, it's a row up. And meanwhile, for the 4.5b, it represents the same set of the entities, but refers the hierarchy where the department is over here, have the employees under them. So it's reverse. Okay. And then a simple databases is represented in figure 4.6a and b. Okay, for the 4.6a, a tree where the each department of 1a, okay, here over here, 1a and 1b has a list of employees. Yeah, so they are employees John and employees Rohit. Meanwhile, for the marketing 1b, yeah, they have Jack and Mac. So let's figure out the B figure. Okay, in this B figure, it's another tree showing the opposite relationship. Yeah, where the each employee, like Sunil, and Puneet, yeah, they work in different. They work in two departments. Yeah, is the testing department and developing department. So this database shows the many to many relationship. Okay. Now the images in the slides illustrates the transformation of an entity relationship or ER diagram into a tree structure and how the simple database represents this structure. And we have this figure of ER diagram over here. Yeah, it's figure 4.7. Okay. So we have an employee entities over here. Okay. Sorry. employee entities over here, and then also have the department over here. And the relationship uh, working for, yeah, which is connects the employee with the department with the descriptive attributes, yeah. So the descriptive attributes is this one. So this is the descriptive attributes. So the working hours, it indicates the number of hours an employee works for a department. Okay. For the figure of 4.A over here, we have an A and B figure. Okay, for the for this figure, it shows how the AR diagram is represented in a hierarchical or tree format. Talking about the descriptive attributes, so the working hours attributes cannot be directly represented in the relationship and thus from separate records in the tree structure. So what's the difference between A and B? So for the 4.8A, this more focus on the department as the root, okay, with a hierarchy of working hours leading to employee. Meanwhile, for the B, it has the employee as the root and then followed by working hours and then associated by the department. Okay, the sample databases, yeah, we can see in this figure the 4.9, yeah, over here. In figure A, yeah, and in figure B over here. So this figure provides a real-world data examples following the structure in figure 4.8A and 4.8B. So in 4.9A, yeah, here, it's focused on the department like cells. 1A and 1B. So the working hours and employees, for example, John in this case, with their details, the salary and the age and salary, and then for figure 49B, it's focused on the employees like Punit and then Sunil. Okay, it lists the working hours and the department. Yeah, for example, in this case, developing and testing. Okay, So the descriptive attributes in the tree structures is the working hours. The working hours attributes cannot be directly represented in a tree because it should be links between the entities and it cannot hold the attribute values. Therefore, the working hours is represented as a separate node in the tree. Yeah, as you can see here, it's a separate node in the tree. Yeah, also this. So this transformation demonstrate the shift from a relational representation in an AR diagram to a hierarchical structure and making the data traversal simpler but introducing a complexity when dealing with the attributes that are inherently part of the relationship. Now let's move on to operation. So there are some operations, yeah, in a hierarchical database, and everything is arranged in a tree-like structure. So we can perform four main operations on this data. The first one is insertion, deletion, updation, and retrieval. So the insertion operation, it's about to add a new records to the base. So in simple terms, if we are adding a parent records like the root of the tree, it will create a new tree. If you are adding a child record, and then you need to add its parent first, because a child cannot exist without a parent in this model. Okay, so if we think like a family trees, every child needs a parent to exist. Okay, and the second operation is the deletion operation. So the deletion operation is to remove a record from the database. And to delete a record, we first need to select it and make it the current records. And if a parent is deleted, all its children get deleted too. So it's just like a cutting down a branch of the tree. It takes everything below it. And the next operation is called update operation. Yeah. So it allows you to update or change the data in an existing records. Yeah. First, you need to choose which records you want to update, and then you can modify it like changing a piece of information on a form. Again, you need to make it the current records to update it. And the last operation is the retrieval operations. So it helps you to find and fetch the data from the database. Imagine you are searching through a family tree and then you start at the top, or we can say from the root, and follow the branches to find the person or records you are looking for. And this process is called retrieval because you are fetching the data. Now let's take a look at virtual records and how they help to solve a common issue in a hierarchical databases. So, in a tree relationship, the tree structure, it's very difficult to represent many-to-many relationship. For examples, an employee working in multiple departments, the usual way to handle this would be to duplicate the data essentially and then copy the same information in multiple places. And this can lead to data replication, right? And duplication kind of thing, which is actually is not efficient and could result in inconsistent data if changes are not made in every copy. So the solution is, instead of duplicated data, we use the virtual records. So the virtual records doesn't store the actual data. Instead, it acts like a pointer to the original data. Okay, this allows us to keep just one version of the actual data and place the virtual records where needed to reference to it. So by using the virtual records, we can maintain the data consistency, and there's only one version of data. So we don't have to worry about making the same update in the multiple places because it's very inconvenient, of course. Although virtual records avoid the data duplication, they use they still use what is called an extra storage space because we need space to store these pointers. And if you want to see the examples of the virtual records, we can see in the figure over here. So the diagram shows an employees like Puneet, yeah, here, Puneet, Sunil, and Sam, along with their details, yeah, such as the age, and then salary, and then the department they're working for. So typically in a hierarchical structure, if an employee is a part of multiple roles or department, their information might need to be duplicated under each role. This will lead to data replication. So the virtual records, yeah, it's over here, is instead of duplicating the same employee's information in multiple places, which is inefficient, the virtual records are used. So the boxes in the lower part of the diagram, yeah, over here, represents these virtual records. And these virtual records don't store the actual employee data, like age or salary, etc. Instead, they contain a pointer to the real employee data. Yeah, like Puneet or Sunil or Sam. Yeah. So it avoids the need to duplicate that data in each department or time slot as shown in the 9 a.m. to 5 and 5 p.m. to 7 p.m. shift. So why we use the virtual records? So by using these virtual records, the system will maintain consistent. The actual data is only stored in one place, and whenever needed, the multiple departments or shift, the virtual records will point to original data. However, it still have some drawbacks. While this approach avoids duplication, the virtual record still takes up some storage for the pointers themselves. So how to optimize a tree structure diagram to make it more efficient? In the hierarchical model, the tree structure can get a bit complex and slow to navigate, especially when dealing with large amounts of data. So, to address this, there are several improvements we can make. Okay, so we have a problems here. Yeah, it's called the traditional tree structure. Use parent-child pointers to navigate relationship between records. And this can sometimes make the structure more complex and slower to move through, especially if the tree is large or has many levels. So the solution is to optimization technique. To improve the efficiency of the tree structure, we can use the following techniques. Yeah. The first one is to use leftmost child pointers. Yeah. So instead of pointing to every child, we only point to the first child, and this makes the structure simpler. And the other children are connected using the next sibling pointers, which I'll explain next. And then next sibling pointers. Okay, each node is linked to its next sibling, allowing us to easily move between the children on the same level. So this cuts down on the complexity and helps us to navigate faster across the tree. And then we also have what is called pre-order threads. So these techniques helps with traversing or moving through the tree quickly. It allows us to visit the nodes in a predefined order without getting lost or stuck at a certain levels. These optimizations make the tree easier to navigate and reduce the time it takes to access and update the data. They also help the structure simple and organized even as the database grows in size. So we have a diagram here. So this is the examples of how they optimize tree structure diagram. So for the leftmost child pointer in a traditional tree structure, each node would typically point to all of its child nodes. Here, instead of pointing to every child directly, each parent node, yeah, for example, 1B marketing only points to its first uh, or leftmost child, in this case Mac under 1B. Okay, this will simplify the structure and reducing the number of the pointers needed. And then the next sibling pointer, yeah, the next sibling pointer. So after we know that leftmost child, how do we navigate the other children? This is where the next sibling pointer comes in. For example, after reaching the A1 cells, the next sibling pointer allows us to jump in to 1B marketing without having to go back to the parent. And this makes it easy to move horizontally between the nodes, yeah, on the same level. And the next one is the pre-order threads, yeah, pre-order threads. It's used to allow the fast traversal of the tree. They make sure that nodes are connected in the order we need to visit them. For example, once we finish with the John under 1A cells, the pre-order track guides us to directly to Rohit, the next node in the order we want to visit. This helps to avoid the complexity of retracing steps and allows us for smooth traversal across the tree. Okay, so by using the leftmost child, next siblings, and pre-ordered threads, we reduce the complexity of traditional tree pointers and then to make navigations through the tree faster and more efficient. So here are some advantages and disadvantages of the hierarchical model. When it comes to advantages, we are talking about the simplicity. So it's easy to understand and manage due to its parent-child structure. And users can easily follow the relationship between the data. Next is about the data integrity. So the relationship between the records ensure the data accuracy, and each child is linked to only one parent, maintaining consistency. And then the security, you can only access a child record if you have access to its parent, so it's secure. And this adds layer of security by controlling the data flow. It's also efficiency. The model handles one-to-many relationship very well. This makes it ideal for large databases with clear parent-child connections. And when talking about the transaction handling, the fixed structure makes it efficient to process a large number of transactions quickly. However, it also have some disadvantages of the hierarchical model. The first disadvantage is about the replication of the data. Sometimes the data must be duplicated in the different parts of the hierarchy. This can lead to unnecessary data redundancy. It is also complex. Yeah. Managing and changing the database requires a deep understanding of how the data is stored. And expanding the system or making changes is often challenges. It's also inflexible because the model doesn't handle complex relationship like many-to-many very well. It's mainly suited for one-to-many structures, limiting its versa- versatility. versatility. And it's also limited querying. The model lacks modern tool for flexible querying, so its retrieving data can be difficult and time consuming. And talking about the management issues, any changes to the data structures will require major or significant updates to the database system, and this will make the maintenance more complex. And then the operations like insert, delete, and update can be slow and difficult to perform because this is especially for the large databases. All right, let's move on to the next model. It's called the network model. So in this case, in this section, we will understand how the network model based on a craft structure. So the previous hierarchical model is the tree structure. Now the network model is more like a crab structure. Okay, so the network database is uses a crab like framework. Yeah, it consists of records that are interconnected through the links. So let's think of it like a web where each point or records is tied to the others. And some key components about the network model is records and linked, where a records is like a data container. It holds collections of attributes and each with only one data value. For example, a record could represent an employee with attributes like name, age, and salary. And then link. So link is the connection between two records. It shows how the records relate to one another. So for instance, if one record is an employee and another one is a department, so the link connects them to show which employee belongs to which department. So the network model is essentially a collection of graphs, and each graph maps the relationship between different pieces of data. And this structure allows for more complex relationships unlike the simpler models. Now let's explore graph structure diagrams, which are a key feature of the network data models. So these diagrams help to visualize how different records are related within a database. So we have a rectangular boxes here. It's for uh, represent various record types. And each box is a unique record, like an employee or department containing specific information. And think of these boxes as of individual profiles, each of them holding vital details about a person or entity in our system, something like that. And then the lines, yeah, the lines connecting these rectangular boxes, yeah, represents links between the records, yeah, and this link shows how the records are related, similar how to people interact in the social network. So, the main purpose of the graph structure diagram is to specify the overall logical structure of the database. It gives us a clear view of how the records are interconnected and allowing us to understand the data organizations and relationship between one and another uh, attributes. Okay, so consider the relation of working for between employee and the department as the examples for this case. So the record employee consists of three attributes, uh, includes name, age, and salary. Meanwhile, for the records department, consists of two attributes is the department ID and department name. Okay, so this is a diagrams for working for relationship. So in the context of the network models, this is a one-to-many relationship that each entity in the relationship exactly one entity and exactly many entity from the other side. Okay, so there is a relationship between these entities of department and employees. So one department, since it's one to many relationship, so one department can have multiple employee. It's more than one employee because it's one to many relationship. So for department of sales, it has two employees, John and Rahid. So that's why it's called one to many relationship. And the next one is one to one relationship, yeah, between these two entities still, employee and department. So since it's a one-to-one relationship, so each employee works exactly in one department and each department has exactly one employee. And this is depicted by the arrows connecting the employee and department. So for the examples of the database, John works in department of sales. Meanwhile, Jack works in department of marketing. In this diagram, 4.15 illustrates the many-to-many relationship between two entities, yeah, still employee and department. So since it's a many-to-many relationship, so an employee can work in multiple departments and a department can have multiple employees. This is shown in the lines connecting multiple employees to multiple departments over here. Okay, so this type of relationship means that for each instance of an entity, in this case an employee, there can be many related instances in the other entity, in this case a department, and vice versa. So the diagram we have shared in the schema is simple data related to employees and departments, yeah? So we have descriptive attributes, yeah? So since the attributes such as working hours are part of the relationship and not the entities themselves, this indicates that the use of a ternary relationship where working hours depend on both employee and department. So we need to create a new record, or we can say a weak entity to hold the attributes for a relationship. So for this figure, uh, It shows the records for Puneet, Sunil, and Sam, along with their working hours, yeah, and their different department. So each record shows the attributes and the working hours and the relationship between working hours and the department as the key here. The next one is the case of ternary relationship. Let's consider the three entities here. We have an employee, and then we have department and a company with no descriptive attributes. Yeah. So here we make records for each entity and one more records, which is called an R linked. Yeah, it's R linked. Okay. So R linked, that is used to connect the rest of the records. The R linked is an empty records or contained a unique identifier. So in this case, we have an R link here. It's 1, 2, 3, 4, and 5. This is the R linked. So it connects the rest of the records. Okay, this is actually an empty records, but it's contained a unique identifier to connect the entities, one entities, one records to another records, something like that. Okay. And now we're dividing into the network data models, focusing on the basic operations we can perform within this framework. It's almost the same with the previous models. We have the insertion, yeah, is to add a new records to the database. It's a deletion, yeah, it's to remove records from the database, and then the updates, it's to update the attributes or columns of an existing records, and to retrieve the data from the database. Okay, that's all of the chapter for part 1. I will see you in the next sections of chapter 4 after the midterm exam. Okay? If you have any questions, just send me emails or you can post it in the discussions. Okay? Goodbye.